Thank you. So I'm not going to challenge Belinda to say that our boundary is the most important, but to quote Marlene and Johan, water is the bloodstream of the biosphere. It is the mother of biosphere processes. Water is the origin of life. Water is what you look for when you go on a Mars expedition. So water is omnipresent, it's everywhere, it's mediating and regulating almost nearly all of the other planetary boundaries. And if you read carefully in the 2009 and 2015 paper, it says the water planetary boundary is supposed to represent precipitation patterns, soil moisture, that regulates carbon uptake, that regulates biomass production, not only the aquatic life that the current freshwater boundary as a proxy variable is supposed to represent. So I worked with moisture recycling, so the evaporation that provides atmospheric moisture to supply rainfall. And so when you look, from my perspective, on the current water planetary boundary, on water withdrawal, I ask questions. So how does that proxy variable represent such a boundary? And Tom Gleason at University of Victoria, he asked questions too, as a groundwater hydrologist. How does the role of groundwater as a base flow, which can transition a stream from perennial to ephemeral if it's treated? And how does the groundwater role for sea level rise accounted for through this proxy variable? So for the past year, we undertook the work to try to reimagine or integrate and illuminate the whole water cycle's modification role. And you see, water is directly linked to climate through carbon uptake processes, through albedo, through cloud formations. And so to capture all the facets of the water cycle, we proposed to capture the 5 major stores in the Earth system: the soil moisture, the atmospheric water, frozen water, surface water, and groundwater, and categorize the role for the Earth system through Earth system functions, so hydroclimatic function, the hydroecologic function, the transport, and storage. And it's complicated. So it's a challenge to, because it's so heterogeneous and so omnipresent, how to do that in simple. I think at least we managed with a hand rule with 5 water stars. But then I think we're excited to propose 6 sub-boundaries, because the atmospheric water, we propose to have both evaporation and precipitation. And then so the second challenge is to aggregate. The current planet boundary is aggregating by volume. But we propose also to aggregate maybe by the area that is transgressed. Or we're thinking maybe by chipping elements from a top-down approach, asking what are the Earth systems, what are the biomes like the Amazon or the monsoon system that is most sensitive to hydrological processes and also connected directly to the Earth system stability. And then set the boundary and then explore what the water planetary boundary, how can we be used. So we're the process, or we have, this paper is now, we're resubmitting it today, hopefully, actually. And we're in the process of trying to actually establish the control and response variable and to quantify. So that's where we are. If you look at the sections in the 2009, 2015, it's one section on freshwater. But this work, when we started, we also thought it's going to be one paper. But just as a kind of a reminder of how complex it is, this is ending up at least 4 papers, manuscripts that we have in process now. So yeah, thank you.